Hello students, today we'll be solving a numerical on Routh stability criteria. The problem given is the characteristic equation of the system is given in the problem and they're asking us to find the system whether it is stable or no using the Routh criteria. Okay. Now the characteristic equation given is this. Okay, they have given the characteristic equation. Now, we are supposed to find out whether the system is stable or no. Okay. As we can see in the characteristic equation, all terms are positive and no coefficient is missing. So we can proceed with the Routh array. Okay. So the Routh array is given below. So as we can see in the characteristic equation, the maximum degree, okay, is 4. Okay, it is 4. So your Routh array will start with the term s raised to 4. Okay, and s raised to 4 is basically a even. 4 is basically a even term. So first row will consist of all even term coefficients. So first s raised to 4 coefficient is 1. After s raised to 4, the next one which I am going to consider will be, for this particular row, will be s raised to 2 because 2 is even. So the next term will be here 21 and then the 20. Okay. And in your Routh array, it's always written like this. If first a row is s raised to m, the second row will correspond to s raised to m minus 1. So in our problem, in this particular problem, m is 4. So the next will be s raised to 3. After that, it will be s raised to 2, s raised to 1, and the last one will be s raised to 0. Okay. Now we will proceed. Now the second row will be corresponding to all odd coefficients. So it will be 6 here because s raised to cube coefficient is 6, and then it will be 36 here, and here it will be 0. Okay. Now next, your s raised to 2 terms of Routh array will be calculated by using previous 2 rows. Okay. So suppose I am saying that s raised to 2, the first coefficient of this row is x and this one is y. Okay. Let us see how this x and y is calculated. Okay. To calculate x, we are going to use the previous 2 rows. Means I am going to use this row terms and this row term. Okay. So these 2 rows I'll be using. Okay. So the formula is 6 into 21, okay, minus 36 into 1. Okay. So it will be 6 into 21 minus 36 into 1 divided by, I have to take this term, okay, which is 6. Okay. So when I solve this, this comes to 15. Okay. Similarly, the y will be calculated using 6 into 20 minus 0 into 1 divided by 6, and it comes to 20. Okay. So here I'll replace my x and y with the terms which I have obtained, that is 15 and 20. Okay. After that, similarly way, the procedure which we followed for s raised to 2 terms, we are going to find out the remaining 2 rows, and it comes to 28, 0, 0, and 20, 0, 0. Okay. Now once you have finished this, after that we have to declare whether your system is stable or no. Okay. So for that case, we consider the first column. We consider the first column of your Routh array. We concentrate on first column of your Routh array. Okay. As we can see here, all the terms are positive and there is no sign change. Okay. Then we can say that this particular system is stable. We have to just observe the first column of your Routh array, whether there is any sign change, and if there is a sign change, then the system is unstable, and if there is no sign change, then your system is stable. As we can see in our problem, the first column, there is no sign change. Okay, so there is no sign change. There is no sign change in the first column. Hence, the system is stable. Okay. Okay. So thank you, students, for your attention. Okay.